Welcome to Study Loop.
Okay, let's take a look at the question. The question is asking us first draw a ray diagram to represent the situation. Also show the path difference. Okay. So this is the graph I draw. So you see this is a double slit here, and the separation of the slit is 0.025 millimeter, and the distance between the slit and the screen is 2 meters. Okay. And spatial separation from the zeroth order band to the third bright band is 15 centimeter, and the path difference should be 3 lambda. Since we're talking about bright band, so it's constructed interference. So it's m lambda. The third one is 3, since it's from 1 to 3. Okay, 0 doesn't count because if you plug in 0, there will be no path difference. Okay, it's all because this m lambda, and m can be equal to 0, 1, 2, 3. 0 doesn't count because if we plug in 0, it's gone. So the smallest number we can start with is 1. So the third bright band should have the m value of 3. So 3 lambda. Okay, and that's the path difference. And for all this information, we can actually get some kind of quantity. Let's think about this. Okay, so let's see what we know from the question. The separation of a slit is 0.025 millimeter. So let's see. So D is equal to 0.025 millimeter, and L is 2 meter. M is 3, since we're talking about the third order bright band. And we also know the spatial separation between zeroth band and third bright band is 15 centimeter. So we can actually figure out lambda. Okay, since ym equal to m lambda L divided by D. So lambda is equal to y3 times D divided by ml, which is 3L. 3L. So that will give us y3 is 15 centimeter. So 15 centimeter is 15 times 10 to the negative 2 meter. Since 1 centimeter is 10 to the negative 2 meter, D is 0.025 times 10 to the negative 3 meter, and 3 divided by 3 times 2 meter. And eventually we'll get lambda is equal to 6.25 times 10 to the negative 7 meter, which is lambda equal to 625 nanometer. It's because 1 nanometer is equal to 10 to the negative 9 meters. So that's what we got. And since we got the wavelengths from this question, what else can we learn about from all this information? Well, if we got lambda, which is wavelengths, we know the separation D, and also we know the order, then we can actually figure out the angular deflection. We can name this formula. If you guys are interested, you guys can totally work on it by your own, and I will just leave the formula here for you guys. And you guys probably already know, which is sine theta m equal to m lambda divided by d. Lambda is known, m is known, d is known, and then we can figure out angular deflection. So yeah, so that's what we can learn from the question and all the calculation we just did. And that's my answers. Thank you.